Today we are discussing about set. Sets are ubiquitous in modern mathematics. The more specialized subject of set theory is part of the foundations of mathematics from which nearly all of mathematics can be derived. Set can be defined as a well-defined collection of elements or members. Set is applied in various streams of life. Now let's take a look at the applications of set.
Applications of sets in business and economics. We all have a group of some objects, collection of our favorite things, sets of books, a list of cities and countries in our life. These all are sets and we come to their usage in our daily life. So, what is a set? A set is a collection of well defined objects. Apart from their mathematical usage, we use sets in our economical life. Kitchen is the most relevant example of sets. Our mother always keeps a kitchen well arranged. The plates are kept separate from bowls and cups. Sets of similar utensils are kept separately. When we go shopping in a mall, we all have noticed that there are separate portions for each kind of things. For instance, clothing shops are on another floor, whereas a food court is at another part of the mall. Every school or company have different sets of rules which have to follow by every student and employee. There are disciplinary laws, rules for leave, hostel rules, timing rules, and many others. Hence, all different types of rules are separated from others. What about its application in an economical life? It helps to make better decisions and to solve real world problems. It even helps in public policy analysis and evaluation. Apart from this, even in the case of our bank, or in the representative house, or in the case of playlist, universe, everywhere we can find that sets. The importance of sets are quite vital and it's a very important and it's very common in our day-to-day life.
There are numerous applications of matrices both in mathematics and other sciences. Some of them merely take advantage of the compact representation of a set of numbers in a matrix. For example, in game theory and economics, the payoff matrix encodes the payoff for two players, depending on which out of a given finite set of alternatives the players choose. Text mining and automated the source compilation makes use of document term matrices such as TF, IDF, to track frequencies of certain words in several documents. Metrics in computer science. In computer-based applications, matrices play a vital role in the projection of three-dimensional images into a two-dimensional screen, creating the realistic seeming motions. Eigenvector solvers are used in the PageRank algorithms, which are used in the ranking of web pages in Google search. Graphic software uses matrix mathematics to process linear transformations to render images. Statistics also makes use of matrices in different forms. 94 descriptive statistics is concerned with describing datasets, which can often be represented as data matrices, which may then be subjected to dimensionality reduction techniques. The covariance matrix encodes the mutual variance of several random variables. 95 other techniques using matrices are linear least squares, a method that approximates a finite set of pairs.
Chemistry makes use of matrices in various ways, particularly since the use of quantum theory to discuss molecular bonding and spectroscopy. Examples are the overlap matrix and the Fock matrix used in solving the Ruthen equations to obtain the molecular orbitals of the Hartree-Fock method. In geology, matrices are used for taking seismic surveys. They are used for plotting graphs, statistics, and also to do scientific studies in almost different fields. In robotics and automation, matrices are the base elements for the robot movements. The movements of the robots are programmed with the calculation of matrices, rows, and columns. The inputs for controlling robots are given based on the calculations from matrices.
Hello all, I'm Maran Vijay. Today I'm here to explain application of LPP in economics. Many models in economics can be expressed as inequality constraint optimization problems. A linear program is a special case of this general class of problems where both the objective function and the constraint functions are linear in the decision variables. However, in economic theory, the optimal solution is usually shown in qualitative abstract terms, while linear programming yields specific numerical solutions to the particular optimization problems. The use of linear programming is expanding fast due to the use of computers, which can quickly solve complex problems involving the optimal use of many resources which are given to the firm in any particular time, and thus set constraints on the firm's choice. Linear programming can be considered as providing an operational method for dealing with economic relationships, which involves discontinuities. It is a specific approach within the general framework of economic theory. Now, sensitivity analysis is a way to evaluate the robustness of the solution. Sensitivity analysis is the study of how the uncertainty in the output of a mathematical model or system can be divided and allocated to different sources of uncertainty in its inputs. And it also allows a manager to have a better understanding of constraints and limits of the problems.
Application of LPP in business. In the field of business and management, linear programming is a method for solving complex problems in the two main areas of product mix, where the technique may be used where it is difficult to decide just how much of each variable to use in order to satisfy certain criteria, such as maximizing profit. Linear programming in business. Businesses use linear programming methods to determine the best ways to increase profits and decrease operational costs. Linear programming methods enable businesses to identify the solutions they want for their operational problems, define the issues that may alter the desired outcome, and figure out an answer that delivers the results they seek. Although the phrase linear programming came into use well before the widespread use of computers, software packages are available that replicate the linear programming processes. Linear programming is used to solve problems in many aspects of business administration, including product mix planning, distribution networks, truck routing, staff scheduling, financial portfolios, corporate restructuring.